Okay, today we are talking about solving equations by adding or subtracting. This is chapter 4, lesson 3. Okay, so just like we did yesterday, we're going to skip this top part on focus on why. We're going to start here with the first concept where we're solving equations by adding. It says a mathematical sentence that contains an equal sign showing that two expressions are equal is called an equation. So yesterday and so far we've worked with a lot of our problems have been expressions where there's no equal sign there, and we evaluate those expressions. Now we're actually going to solve different equations that contain an equal sign. It says you can write the equation 120 plus x equals 68 to model the situation above, which obviously we didn't go through. A value for the variable, remember the variable is the letter, that makes an equation true is called a solution, okay? So taking a look over here at the left, we have 120 plus x equals 168. If I plugged in the number 40 for the variable x, I would get 120 plus 40 equals 168. And clearly 120 plus 40 is 160, and 160 will never equal 168. So we know that when we replace x with 40, that our statement is false, okay? That equation is false. On the right, though, during this equation, if I have 120 plus x equals 168, instead of replacing or substituting with 40, we substituted with 48. And that then shows me that 120 plus 48 gives me 168, and 168 is always going to equal 168. Scrolling down here, it says for 120 plus x equals 168, the solution is 48. The process of finding a solution is called solving the equation. Okay, so we're always going to be solving some kind of equation. It says you can use inverse operations to solve an equation. Inverse operations is something that you will need to know, and you'll often frequently hear me say, what is the opposite of a certain operation? So you can think of inverse operations as opposite. Okay, what is the opposite of a certain operation? And by operation, we mean addition, subtraction, multiplication, or division. Inverse operations undo each other. For example, to undo the subtraction of 5 in the equation y minus 5 equals 10, you would have to add 5 to each side of the equation. So, to summarize that, in words, if you are talking about the addition properties of an equation, it says if you add the same number to each side of an equation, the two sides remain equal. For any numbers a, b, and c, if a equals b, then a plus c has to equal b plus c. Here they show you an example in numbers. And down at the bottom it says equivalent equations are equations that have the same solution. Because the equations y minus 5 equals 10 and y equals 15 have the same solution, 15, then they are equivalent equations, or they are equal equations, okay? Okay, so let's take a look at what this looks like. I'm just going to rewrite the problem. X minus 7 equals negative 4. So the first thing that we need to do is we need to undo our subtraction there. So here, the whole purpose of solving equations is to get the variable, which is x in this case, by itself. So I look at, here is one term, and it's being separated by subtraction, and here is another term, okay? I have to think of how can I get x completely by itself. I need to isolate x and make sure that it's positive. Well, right now we know, because there's nothing in front of x, that it is positive. And the inverse operation of subtraction is addition, or the opposite operation. So I would need to get rid of the 7, the negative 7. I would need to add 7 to both sides. And then whatever I do to one side, I have to do to the other side, because we're talking about equations, and that is called balancing an equation. Negative 7 plus 7 more cancels out and gives us 0. And we're left with just a positive x on this side that equals a negative 4 plus 7 really gives us a positive 3. So in this case, I would say that x equals 3, okay? Now, the second thing that you were asked to do is solve the equation, and then you needed to check your solution and then graph it on a number line. So to check our solution, all we do is take what we solved for x and substitute it back into our equation. So we really get 3, which was what we said x was, minus 7 equals negative 4. And now all of you in here should be able to understand that 3 minus 7 gives me a negative 4, and negative 4 always equals negative 4. So you are always able to check your solution, make sure that you have found the correct solution to the problem. And then the last thing they ask us to do is to graph on a number line. So I just make a quick sketch of a number line, and I show you that x right here is equaling a positive 3. You could go ahead, you wouldn't have to maybe number out all of those. I would be okay with you saying, here is a positive 3. I need to graph that on the number line, which means that you plot that point there. And then I just need to say that this is 2 and this is 4. If I can see at least one or two numbers on each side, that's fine. All right, coming down here to B. B says, and they're just, oops, excuse me. That was what I didn't mean to do that. 13.9 equals n minus 9.7. All right, so what we need to do is get n, our variable, completely by itself. We are solving for n. Here I need to get rid of any terms that don't have the variable next to it. So 9.7 is another term that doesn't have the variable next to it. So I would need to add 9.7 to both sides because I know that the opposite or the inverse of subtraction is addition. These are going to cancel out and make a 0 because negative 9.7 plus 9.7 gives us 0. And I'm left with a positive n equaling and negative 13.9 plus 9.7 more gives us 4. Having a brain fart right now. Well, excuse me, 4.2. Yeah. All right. So then the last step for me to do would be to check my solution and graph on a number line. I'm not going to take the time right now to check your solution. All you would do is you would plug 4.2 back in for n right there to check your solution. And then to graph on a number line is the same thing that I just showed you before. If you wanted to show me this instead, you could say 4.2 and you could graph that. And I would be actually okay with you saying 4.1 and 4.3 even if you wanted to. Here they give you the whole numbers and then the integers, those negative integers. You could do it one of two ways. It doesn't really matter to me which way you do it. All right, so then the second thing we'll talk about is solving equations by subtracting. So some equations can be solved by subtracting the same number from each side. Once again, notice how important that is. We are subtracting the same number from each side. In order for us to solve that equation, whatever you do to one side of the equal sign, you have to do to the other side. So that's called balancing your equation. All right, so in the key concept in words here, it says if you subtract the same number from each side of an equation, the two sides have to still remain equal. So for any numbers A, B, and C, if A equals B, then A minus C has to equal B minus C because we know that these two numbers are equal. They give you some examples here, and we'll just move on to the next slide after you get those written down. So let's take a look here. We have 23 equals Y plus 10, okay? So in order for us, again, to solve for the variable, we are solving to come up with a solution. I need to get y completely by itself, and y also needs to be positive. Well, in this case, y is positive, but it's not by itself on that side of the equal sign. So I need to get rid of any terms, which in this case would be a positive 10, that do not contain a variable. So the opposite or the inverse of addition is subtraction. So I know that I need to subtract 10 from both sides. And whatever I do to this side, I need to do to this side. Okay? And again, that's called balancing the equation. I can't stress that enough because you're going to need to know this throughout the rest of forever. So I have a y completely by itself, and 23 minus 10 gives me 13. Okay, again, I can take this and check my equation. I plug 13 back in for y, I substitute it back in, and I'm left with 23 plus 13, or excuse me, 23 equals 13 plus 10, and in this case, 23 has to equal 13 plus 10 gives me 23. So we know that 23 is always going to equal 23, which means that we came up with the correct solution. All right, B down here says m plus 6.7 equals 3.4. Okay, I need to get m completely by itself on that side of the equal sign, so I want to get rid of any terms that don't have the variable next to it. The opposite of addition, or the inverse of addition, is subtraction, so I want to subtract 6.7 from this side, and whatever I do to one side, I have to do to the other. All right, so now I'm left with these, remember, equals 0, so I have m equals, and 3.4 minus 6.7 more gives me a negative, what is that in my head, 2 point, I can't think, gives me a negative 3.3, okay? Again, you can go back and check your solution. So I would just take 3.3 and I would plug this back in for my m, which would leave me with a negative 3.3 plus 6.7, and that would have to equal 3.4. And on your calculator, you would be able to check if that were correct. Okay. All right, so then the last slide here is our word problem. It says, Pillar is making digital scrapbooks as gifts for her family. After saving her current work onto a CD, the CD is 5/6 full. If the CD was 1/3 full before she started saving, what fraction of the space on the CD do the new pages occupy? So in words, the first thing we need to figure out is, hey, we're taking our starting amount and we're adding the amount for the new pages. And we know that that has to equal the new amount, or the new total, okay? So the first thing that we need to know is, do we know the amount for the new pages? We shouldn't know that. And when you don't know something, you plug in a variable. The starting amount, we do know though, so let me uncover this really quick. This just tells you that the amount of new pages is going to equal X. But the starting amount, they tell us, is 1/3, okay? So we know that it's 1/3 full. And you're adding those together to find the total amount, okay? And then we know that X was the amount of pages, that's where we get this from, and that has to equal 5/6 because the CD is full at 5/6, right? All right, and this is your indicator there. They take this and they bring that down to here, and we know that is the same thing as saying equals. So now we've got our equation that we can solve, okay? I need to solve for X. So I have 1/3 plus X equals 5/6. I need to get rid of everything on the left side that does not have an equals, or excuse me, an X or a variable next to it, which would be this term. So this really, since there's nothing in front of it, we know that it's a positive 1/3. The opposite of addition is subtraction. So I'm going to need to subtract 1/3 from both sides, and those are going to cancel now. Remember, they're going to equal to 0. I have X that is completely positive and by itself, so I have X equals, and because I subtracted 1/3 from this side, I have to subtract 1/3 from the other side. But keep in mind that, and actually I'm going to write it over here so it's easier for us to see. If I subtract 1/3 from this side, remember that we cannot add and subtract unlike fractions, okay? So in order for me to come up with a common denominator, I have to find that least common multiple between those two, which would be 6. So I have to multiply the numerator and the denominator by 2 to come up with 6 as a denominator. So I really get 5/6 minus 1 times 2 gives me 2 all over. 3 times 2 gives me 6. And I know that 5 minus 2 all over 6 is the same thing as 3/6. I know that 3/6 can be reduced to 1/2. So X is going to equal 1/2. Now the last thing you need to do is, for all word problems, make sure you are checking back and figuring out what they're asking. It says, what fraction of the space on this new CD should the pages occupy? Half of that space.